Okay guys, so here is an example of a rotational kinematics problem. We notice that it tells us about this automobile slowing down from 4,000 to 1,200 RPM in 3.5 seconds. We want the angular acceleration and the total number of revolutions the engine makes in this time. So when we look at a problem like this, we want to make sure that we understand what it's telling us and write all of those things down first. So it starts out at 4,000 RPM. Well, RPM stands for revolutions per minute. It is a rate of spin. So I'm going to call it angular velocity, and original 4,000 RPM. The final angular velocity is 1,200 RPM. The time that it takes is 3.5 seconds. We want to know what's the angular acceleration in part A. Okay, so the first thing I want to do is I don't want to work in RPM just because a lot of times we end up having to convert anyway. So what I'm going to do is convert that to radians per second. So I'm going to take that number and multiply by 2 pi radians per revolution and 1 minute over 60 seconds. And that'll give me the number of radians per second. So 4,000 times 2 pi, and then divided by 60, and I get 419.5. 419.5 radians per second. And using the same exact strategy, I can convert this to radians per second as well. So I'll do 1,200 times 2 pi divided by 60, and I get 125.7 radians per second. Okay, so to find the angular acceleration, I can say that the angular acceleration is the rate of change of angular velocity. So final angular velocity minus initial angular velocity over t. So what we'll do is 419.5 radians per second. Oh, sorry, I got it backwards there. 125.7 radians per second minus 419.5 and divide by the time of 3.5 seconds, and I get negative 83.9 radians per second squared. Okay, and then in the second part, it wants to know the total number of revolutions. So the way I think about that is, if it wants to know the total number of revolutions, it's asking how much has the thing rotated overall. So that's theta that we're looking for. So the equation that's going to get us there is this one. It tells us about angular displacement. So I'm going to put in the original angular velocity in radians per second, which was 419.5 radians per second. Time is 3.5 seconds plus a half. The angular acceleration was negative 83.9 radians per second squared, and the time is 3.5 seconds squared. So I'm going to need to calculate that all out. If I plug it in the calculator, I'm getting 954.4, and the units are going to be radians. I wanted to know revolutions, so I'm going to divide this by 2 pi to get that. So divide by 2, divide by pi. I'm getting about 152 revolutions.